which is if a, b, c is a triple of integers satisfying the system of equations. This is equation 1, this is equation 1, this is equation 2, and this is equation 3. Compute 2a plus 3b plus 6c. Okay, what am I trying to teach you here? Let me tell you this. In these kind of problems, since there is a symmetry, you have AB, BC, CA, 3C, 3A, 3B, and you have ABC, ABC. So there is a symmetry. This problem has symmetry. So whenever you have a symmetry like this, what happens is, what do you mean by symmetry first of all? If I just switch A to B and B to C and C to A, you're more or less going to get the same expression, same equations. Okay, so that's what symmetry means. It doesn't matter what is A, B, or C, but they're slightly twisted though. If you don't have these numbers, it's absolutely symmetrical. But since they added these numbers plus 2, plus 3, and plus 6 different numbers, they slightly twisted the symmetrical aspect of the problem. But anyways, if it is, this is not completely symmetric, but it's like sort of symmetric. So whenever you have similar problems like this, it helps to find, first experiment adding these three. If I add all these three equations, what happens? ABC over 9, ABC over 9, ABC over 9 will give you ABC over 3. And then you have it's on the right hand side, right? So you have AB, BC, and CA. So if I subtract AB, BC, and CA, and then what else is left? Plus 3 times A plus B plus C, plus how many numbers? 6 plus 3, 9 plus 2, 11. Plus 11 equals 0. That's what I get by adding all these. Now, another thing, like I told you earlier, if you simplify one more time, because there is ABC over 3, if I get 3 up there, if I multiply that by 3, I get ABC minus 3 times that, plus 9 times A plus B plus C, plus 33 equals 0. Both are same. I just simplified one. Now whenever you have minus, let's see, yeah, so whenever you have equations like this, it probably helps to see if it is this one, A minus 3 times B minus 3 times C minus 3. Because there is a symmetry, let's look at it. You have ABC, and then you have minus 3B times minus 3, so plus 9B. So let's try to open this up. Okay, I think this expression is going to be, let me multiply these two first. If I multiply these two first, I get AB minus 3B minus 3A plus 9. That's what I get with these two equations. And then I have to multiply that by C minus 3. If I multiply that by C minus 3, I get ABC minus 3BC minus 3AC and then plus 9C and then with negative 3 I get minus 3B minus 3AB, not 3B, minus 3AB, and then minus 3 and minus 3 will be plus 9B, and minus 3 and minus 3 will be plus 9A, minus 27. So you have ABC here, you have ABC there. You have ABC here, here you have ABC there. Let me show with a different color. You have ABC here, and you have ABC here. You have minus 3 times AB plus BC plus CA. You have minus 3 times BC plus AB plus CA. And you have plus 9 ABC, so 9 A, B, and C. So the only thing different is you have minus 27 here. Okay, so this one is that minus 27. So if I have to get plus 33, I have to make it minus 33, right? So this is going to be negative 60. That's what. So this equation and this equation are the same. So let me erase that part. So that's how this equation and that equation, you can try, like since this is a video, you can always go back and check, right? So this is what A minus 3 times B minus 3 times C minus 3 is negative 60. So what do you do next? Well, this might take a long time, so let's try a different strategy here. So this is, let's mark this as equation 4, right? So let me change my color back. And now, if you subtract, see, in symmetry, not only adding we got this. Let's subtract and see. Okay, so if we subtract second equation, from first, so it'll be AB minus BC. You get equation 1 minus equation 2 will give you AB minus BC minus 3C plus 3A equals 2 minus 3 is negative 1. ABC over 9 will cancel. And if you try to factor this, this can be factored as B plus 3 times C minus A. And that happens to be negative 1. Similarly, if you subtract third from second, you will get C plus 3 times B minus A equals negative 3. This is from equation 2 minus equation 3. And equation 3 minus equation 1 is going to give you A plus 3 times C minus B. And that's going to be 2. That's positive because 6 minus 2 is 4. Oh, no, not 2, 4. 6 minus 2 is 4. Okay, so that's what you get. Now this actually is better because if the product of two expression is negative 1, one of them has to be 1. So that means B plus 3 is 1 or minus 1, right? And C plus 3 is, okay, it's better to do it this way. Instead of writing 1 or minus 1, it's better to say absolute value of B plus 3 is 1. And similarly, absolute value of C plus 3 is either 1 or 3. Is either 1 or 3. Why is that? Because B plus 3 can be 1 or minus 1. It's say equivalent to say absolute value of B plus 3 is 1. So if B plus 3 is 1 or minus 1, that means B could be either minus 4 or minus 2. So B could be minus 4 or minus 2. And if C plus 3 is 1 or if absolute value of c plus 3 is 1 or 3, then c could have 4 different values. C could be minus 6, because minus 6 plus 3 is minus 3. Absolute value of minus 3 is 3. And c plus 3, like if c is negative 4, negative 4 plus 3 is negative 1. And absolute value of negative 1 is 1. And if c plus 3 is, if c is 2 or negative 2, if c is negative 2, then minus 2 plus 3 is negative 1. And if c plus 3 is 0, c is negative 3. So now hold on a minute. If c is 0, if c is 0, c plus 3 is 3. So what is the other? I think this is one way I would suggest. Other way, you can plainly take the product as 1 and minus 1, minus 1 and 1, 3 and 1, 1 and 3 and minus 1 and 1 and minus 3, and so on. So this is what I got so far. But b minus 3, if you look at b minus 3 and c minus 3, they both divide negative 60, because the product of these three is negative 60, right? So what happens to b minus 3 when b is minus 4 is minus 7? That doesn't divide 60, right? But when b is minus 2, b minus 3 is minus 5, which does divide negative 60. So b can only be negative 2, not negative 4. B can only be negative 2 because let me write it on the side, because it's not letting me write in that screen. It has some limitations. This can only be because b minus 3 divides 60 according to this here. But when b is negative 4, b minus 3 is minus 7, it doesn't divide 60. So we conclude b's value right now. Now we are not left with, we still don't know what c could be. So if b is negative 2, c could be negative 2 or 0. C could be actually not 3. C is 0. C is 0. C could be negative 2 or 0. But B cannot be equal to C, because B minus C cannot be 0. If you look at this here, B minus C, this is not 0. This is not 0. So B cannot be equal to C. So B cannot be equal to C. So C cannot be negative 2. And for similar reason that C minus 3 also divides 60, this cannot be negative 9 because of divisibility, and C minus 3 cannot be negative 4. I mean, if C is negative 4, C minus 3 is minus 7, which cannot divide negative 60. So C cannot be negative 2 because B and C are different. So the only possible value is C equals 0. So far we found two values. What are those two values? We found B is negative 2 and C equals 0. So since we found B is negative 2, C equals 0, so we can plug in anywhere, right? So if I plug in here, C is 0, so I have 3 times minus 2 minus A is negative 3. So if I take the opposite of that sign, 3 times 2 plus A is 3. So 2 plus A is negative 1. 2 plus A is 1. So A has to be, if 2 plus A is 1, what is A? A is negative 1. That's the only possible value. So now we try to see with with these values of a, b, and c, 2a is going to be -2, 3b is going to be -6, and c is going to be 0, so the value is -8. All right, so that's the end of that problem.